Hari Om. Hello everyone, I'm Sri Jyoti. Welcome back to my channel. In this video, we are going through some case study questions based on applications of derivatives. Look at the first question. A potter made a mud vessel where the shape of the pot is based on f of x is equal to modulus x minus 3 plus modulus x minus 2, where f of x represents the height of the pot. First question, based on the above information, the first question is, when x greater than 4, what will be the height in terms of x? See, here given function is modulus function, right? So first of all, we have to redefine the given function. X modulus x minus 3 plus modulus x minus 2. We know that how to redefine modulus function. Modulus x. Modulus x is equal to minus x when x greater than or equal to 0. Sorry, plus x when x greater than or equal to 0. Minus x when x less than 0. Right? See here, given function is f of x is equal to modulus x minus 3 plus modulus x minus 2. Okay? See, given numbers are 2 and 3. Right? Let's represent these numbers on the real line. That is, okay, minus infinity, 2, 3, infinity. And make the interval minus infinity to 2, 2 to 3, 3 to infinity. So let's write the functions on these intervals. Okay? That is, first of all, minus infinity to 2, or we can write it as x less than 2. And see here, what is modulus x minus 2? How to redefine the function modulus x minus 2? Here, modulus x is x when x greater than or equal to 0. Modulus x is equal to minus x when x less than 0. See here, similarly, modulus x minus 2 is x minus 2 when x minus 2 greater than or equal to 0, that is x greater than or equal to 2, right? Okay, next. That is equal to modulus x minus 2 is equal to minus of x minus 2, that is minus x plus 2 when x minus 2 less than 0, that is x less than 2. Okay, similarly we can write modulus x minus 3. Modulus x minus 3 is equal to x minus 3, okay, plus x minus 3 when x minus 3 greater than or equal to 0, that is x greater than or equal to 3. Modulus x minus 3 is equal to minus of x minus 3, that is minus x plus 3, x less than 3. Okay, now here let's write the functions for these intervals. When minus infinity to 2, that is x less than 2. What is this modulus x minus 3? Here, see, when x less than 3, the function is x less than 3. Okay, less than 3 means here. So, in this interval, what is the function? Modulus of x minus 3. Modulus of x minus 3 is equal to minus x plus 3. It is, see, x less than 3. When x less than 3, what is the function? Minus x plus 3. So, when x less than 2, what is the function? Minus x plus 3. Okay. So, minus x plus 3, that is f of x is equal to minus x plus 3 plus, what about modulus x minus 2? See here, when x less than 2, minus x plus 2. Minus x plus 2, that is minus x minus 2x plus 5. Okay, so when x less than 2, f of x is equal to minus 2x plus 5. Next interval, 2 to 3. 2 less than x less than 3. Okay, so 2 to 3, see, in this interval, that is when x greater than 2, what is the function? Okay, first we need modulus x minus 3, right? So here, look at this, x less than 3. When x less than 3, what is the function? Modulus x minus 3 is minus x plus 3. Okay, plus, next, when x greater than 2, modulus x minus 2 is x minus 2. When x greater than 2, modulus x minus 2 is x minus 2. That is equal to 1. Right? Next interval, 3 to infinity. That is x greater than or equal to 3. Okay. When x greater than or equal to 3, what is modulus of x minus 3? X minus 3. X minus 3 plus, when x is greater than 3 in this interval, what is modulus x minus 2? See, when x is greater than 2, modulus x minus 2 is x minus 2. That is, in this interval, modulus x minus 2 is x minus 2. X minus 2, that is equal to 2x minus 5. Okay, let's redefine this function as f of x is equal to 2x minus 5 when x is greater than or equal to 3. 1 when x 2 less than x less than 3. Minus 2x plus 5 when x is less than 2. Okay. So here it is the redefined function of given modulus function. Okay. What is our first question? When x is greater than 4, what will be the height in terms of x? What is the height? See here, height of the pot. See, given f of x represents the height of the pot, right? Therefore, when x is greater than 4, what is f of x? So here, see, when x is greater than or equal to 3, f of x is 2x minus 3, right? So x is greater than 4, it contains here, right? So x is greater than or equal to 3, f of x is equal to 2x minus y. Therefore, when x is greater than 4, f of x is equal to 2x minus 5. So, here f of x is equal to 2x minus 5 is the height of the pot. Okay. So, the answer is 2x minus 5. Because f of x represents the height of the pot. Next question, will the slope vary with x value? So here, what is the slope of the pot? Means slope of the curve. We know that slope of the curve is nothing but derivation, right? Rate of change. So here, to find the slope, we have to find the derivative of the given function. So what is the redefined function of the given function? F of x is equal to 2x plus 5 when x is greater than or equal to 3. 1 when x 2 less than x less than 3. Minus 2x plus 5. It is 2x minus 5, right? Minus 2x plus 5 when x less than 2. Okay, it is the redefined function of given function. Okay, now let's find the derivative, that is the slope. Okay, so here f dash of x. F dash of x is equal to, what is the derivative of this function? That is 2, it is 0, right? So 2 when x is greater than or equal to 3. F dash of x is equal to 2 when x is greater than or equal to 3. F dash of x is equal to, see, derivative of 1 is 0. 0 when 2 less than x less than 3. Okay, and see, it is minus 2. Minus 2 when x less than 2. See, it is clear that when x changes, when values of x changes, the f dash of x changes. Right? That is, values of f dash of x changes. Means f dash of x means slope of the function. Right? So here slope vary with x value. So yes or no? Yes. Okay. Will the slope vary with x value? Yes. Because when x changes, the slope of the function changes. Third question. What is dy by dx at x is equal to 3? Okay, so first of all, let's write the redefined function. F of x is equal to 2x minus 5 when x is greater than or equal to 3. 1 when 2 less than x less than 3. Minus 2x plus 5 when x less than 2. Okay. Now, here we need to find dy by dx, means derivative, right? That is f dash of x. F dash of x is equal to 2 when x less than or greater than or equal to 3. 0, 2 less than x less than 3. Minus 2 when x less than 2. Okay. So, here we have to find dy by dx or f dash of x at x is equal to 3. See here, we observe that, see, when x is greater than 3, f dash of x is 2, right? What about when x less than 3? See, when x less than 3, f dash of x is 0. See, here values of f dash of x are different on right and left and right side of x is equal to 3, right? So, it is clear function is not differentiable at x is equal to 3. Okay, so the answer is not differentiable at x is equal to 3, right? Because on left and right side of x is equal to 3, f dash of x, values of f dash of x are different. See, when x is greater than 3, f dash of x is equal to 2, right? When x is less than 3, f dash of x is equal to 0. For differentiable function, we have already studied for differentiability, it should be equal, right? That is, left hand derivative, right hand derivative should be equal. But here, these are different. Therefore, this function is not differentiable at x is equal to 3. Look at the fourth question. When the x values lies between 2 to 3, then the function is dash. That is, when x is lying between 2 and 3, that is 2 less than x less than 3, what is the function? Our redefined function is f of x is equal to 2x minus 5 when x is greater than or equal to 3, f of x is equal to 1 when 2 less than x less than 3, f of x is equal to minus 2x plus 5 when x less than 2. Okay, so here our question is, when 2 less than x less than 3, what is the value of function? That is, what is the function? Okay, f of x is equal to dash. See here, when 2 less than x less than 3, f of x is equal to 1. So f of x is equal to 1 is the answer. Next question is, if the potter is trying to make a pot using the function f of x is equal to greatest integer of x, will he get a pot or not? Why? See, given function, that is f of x is equal to greatest integer of x. It is the greatest integer function. And in continuity, we have learnt that greatest integer function is not a continuous function. If it is not a continuous function, then he cannot make a pot. Okay, it will be break in between, right? So for to make a pot, it should be a continuous function. Okay, therefore the answer is he will not get a pot because greatest integer function of x is not a continuous function. Okay, so answer is no, because greatest integer function, that is greatest integer of x, is not a continuous function. It is the answer. Second question, a right circular cylinder is inscribed in a cone. S is equal to curved surface area of cylinder. So it is the given figure. Okay. So here, based on this information, first question is R divided by R1 is equal to dash. Okay, let's find. See, here it is given height of the cone is h1 and height of the cylinder is h, and radius of the cylinder is r, radius of the base of the cone is r1. Okay, now first of all, let's take this angle B alpha. Okay, then first of all let's consider this triangle, triangle OAD. In triangle OAD, tan alpha, what is tan alpha here? Tan alpha is equal to opposite divided by adjacent, right? So opposite means this length is nothing but r. Okay, that is r divided by, what is this height? See, total height is h1 and this height of the cylinder is h. So this height is nothing but h1 minus h. h1 minus h, right? R divided by h1 minus h. Okay, now let's consider the triangle OBC. Triangle OBC. In this triangle, what is tan alpha? Tan alpha is equal to opposite, that is this length, it is nothing but radius of the base of the cone, that is r1, right? So r1 divided by height of the cone, h1, right? So here, now let's compare these two. Tan alpha is equal to this one, tan alpha is equal to this one. Therefore, r divided by h1 minus h is equal to r1 divided by h1. That implies, take this R1 here, okay. That implies R divided by R1 is equal to, take this one here, okay. So H1 minus H divided by H1. So we need to find R divided by R1, right? We have got R divided by R1 is equal to H1 minus H divided by H1. H1 minus H divided by H1. So the correct answer is B. Next question is, find the value of S. What is S? S is the curved surface area of cylinder. What is the formula for curved surface area of the cylinder? 2 pi RH, right? So S is equal to 2 pi RH. R is the radius of the cylinder, H is the height of the cylinder. Okay. So here from this we will write, see we have got this one, R by R1 is equal to H1 minus H divided by H1, right? So from this we will write what is R. Substitute R is equal to. So 2 pi into, what is R? Take R1 here, right? So it will be 2 pi R1 into H1 minus H divided by H1 into H, right? That is equal to 2 pi R1 divided by H1 into H1 minus H into H. So it is the answer, 2 pi R1 divided by H1 into H1 minus H into H. So C is the answer. Okay, S is equal to 2 pi R1 divided by H1 into H1 minus H into H. The third question, find ds by dh. What is S? Surface area of the cylinder is, S is equal to 2 pi R1 divided by H1 into H1 minus H into H. Okay. So here we have to find the derivative of S with respect to H, right? Therefore here R1, H1 are constants. Okay. So now let's write this as 2 pi R1 divided by H1. Let's multiply this by H. H1 into H minus H into H, H square. Okay. So it is constant, right? ds by dh. So constant into 2 pi R1 divided by H1 into here derivative of H1 into H. H1 is constant, right? So derivative of this term with respect to H, that is H1. Okay, that is, suppose here AX, derivative of AX with respect to X is nothing but A, right? So here H1. Okay, similarly derivative of H1 into H with respect to H is H1 minus derivative of H square with respect to H, that is 2H. Okay, so here it is the answer. ds by dh is equal to 2 pi R1 divided by H1 into H1 minus 2H. Next question, find d square s by dh square. Okay, in last question we had found ds by dh, right? That is 2 pi R1 divided by H1 into H1 minus 2H. Here we have to find the second derivative of s with respect to h. Okay, so here also R1, H1 are constants. Okay, so let's differentiate it again with respect to h. That is d square s by dh square is equal to, it is the constant, 2 pi R1 divided by H1 into, it is also constant, right? So derivative of this H1 is with respect to h is 0, right? So it is 0 minus derivative of 2h with respect to h is 2, right? That is equal to minus 4 pi R1 divided by H1. That is the answer. D square s by dh square is equal to minus 4 pi R1 divided by H1. Look at the next question. what is the relation between R1 and R? Okay, so first of all, to find the relation between R1 and R, put ds by dh is equal to 0. Okay, that is first derivative of s with respect to h is equal to 0. ds by dh is equal to 0, that implies it is equal to 0, right? That is 2 pi r1 divided by h1 into h1 minus 2h is equal to 0. That implies, see, it will be goes to here right side, it will be 0, right? So h1 minus 2h is equal to 0, that implies h1 is equal to 2h. Okay, and what is d square s by dh square? That is derivative of this one with respect to h, that is nothing but we had got already minus 4 pi r1 h, sorry, no h, okay, divided by h1. See, we had got it is minus, that means it is less than 0. Okay, therefore here we can say that is surface area S is maximum for H1 is equal to 2H. Okay, surface area is, see, we have got it is second derivative is less than 0, that means it is maximum when H1 is equal to 2H. Okay, for H1 is equal to 2H. So therefore here we can substitute H1 is equal to 2H in this equation. We had got the expression R divided by R1 is equal to H1 minus H divided by H1. Let's substitute H1 is equal to 2H. Okay, that is 2H minus H divided by 2H. That is H divided by 2H. That implies, that is equal to H cancelled 1 by 2. So R divided by R1 is equal to 1 by 2. That means R is equal to, sorry, R1 is equal to 2R. Okay, R1 is equal to 2R. It is the relation between R1 and R. Next question. The shape of a toy is f of x is equal to 6 into 2x raised to 4 minus x square. To make the toy beautiful, two sticks which are perpendicular to each other were placed at point 2, 3 above the toy. Okay, suppose it is the toy and two sticks are placed above the toy at the point 2, 3. Okay, these sticks are perpendicular to each other. Okay, so the first question based on this information, which value from the following abscissa of critical point? How to find a critical point? See here, what is f of x? F of x is equal to 6 into 2x raised to 4 minus x square. It is the function, right? Shape of the toy. So here, we need to find the critical point, right? To find the critical point, we have to put f dash of x is equal to 0. What is f dash of x? F dash of x is equal to 6 into 8x cube minus 2x, right? Here 2x is common, right? Let's take it out. So 2x into 6, 12x. 12x into here 4x square minus 1. Okay. So for critical point, f dash of x is equal to 0, right? That implies 12x into 4x square minus 1 is equal to 0. That implies 12x is equal to 0 or 4x square minus 1 is equal to 0. 12x is equal to 0 implies x is equal to 0 or 4x square is equal to, that is x square is equal to 1 by 4. That implies x is equal to plus or minus 1 by 2. So what are the critical points? 0 plus or minus 1 by 2. So here plus or minus 1 by 2 is the critical points. So B is the correct answer. Second question is, find the slope of the normal based on the position of the stick. See here we know that two sticks are placed at the point 2, 3, right? Here we have to find slope of the normal. To find slope of the normal, we need to find slope of the tangent, right? So here slope of the tangent is nothing but f dash of x, right? f dash of x. F dash of x is equal to 12x into 4x square minus 1. And see, it is placed at the point 2, 3, means x coordinate, x value is 2, y is equal to 3, right? So let's substitute x is equal to 2. So here slope of the tangent at 2, 3 is equal to, substitute x is equal to 2. Here slope of the tangent is nothing but derivative of f of x with respect to x, that is f dash of x. Okay. So at 2, 3, substitute x is equal to 2. That is 2 into 12 into 2, 24 into 2 square 4, 16 minus 1, that is 15. It is 60, 30, 360, right? Okay. So here we have got slope of the tangent at 2, 3 is 360. Then what is slope of the normal? We know that slope of the normal is equal to minus 1 divided by slope of the tangent, right? Slope of normal is equal to minus 1 divided by slope of tangent, right? Therefore, here we have to find slope of the normal, right? Slope of the normal is equal to normal. See, it is mentioned slope of the normal based on the position of the stick. What is the position of the stick? The positions are, sticks are placed at the point 2, 3, right? So, at 2, 3, we have to find slope of the normal at 2, 3, okay? So, slope of the normal at 2, 3 is equal to minus 1 divided by slope of the tangent at 2, 3, that is 360. So, minus 1 by 360 is the answer. Slope of the normal at 2, 3 is equal to minus 1 by 360. Next question is, what will be the equation of the tangent at the critical point if it passes through 2, 3? See here we have to write the equation of the tangent passes through the point 2, 3. See, what is the equation of the tangent? Y minus y1 is equal to slope of the tangent, okay? Slope of the tangent, let's write it as m, okay? Slope of the tangent into x minus x1. And here we have to find the equation of the tangent passing through the point 2, 3, right? So here y minus y1 passing through the point x1, y1, here x1, y1 is 2, 3, right? So y minus 3 is equal to, what is the slope of the tangent? We have got in the previous question, right? That is, slope of the tangent is 360 at the point 2, 3, right? So 360 into x minus 2, okay? That is, y is equal to 360 x minus 360 into 2, 720 plus 3. That is 360 x minus 770. So y is equal to 360 minus 360x minus 770. It is the answer. Next question is, find the intervals in which f of x is increasing. See, what is our f of x? 6 into 2x raised to 4 minus x square. To find the intervals, we need to find critical points. Right? We know what are the critical points here. That is x is equal to 0 plus or minus 1 by 2. Okay. So here we had got f dash of x is equal to 12x into 4x square minus 1. Okay. So here we have to write it in the form of factorization. Okay. Factors. That is 12x into, how can we write this one? 4x square, a square minus b square form, right? That is 2x minus 1 into 2x plus 1. Okay. Now, what are the critical points? X is equal to 0 plus 1 by 2 minus 1 by 2. Right? So, let's make the intervals. Okay. So, here 0, 1 by 2, it is minus infinity, minus 1 by 2, okay, minus infinity, minus 1 by 2, 0, 1 by 2, infinity. So, 4 intervals, we will get 4 intervals, that is minus infinity to minus 1 by 2, minus 1 by 2 to 0, 0 to 1 by 2, 1 by 2 to infinity. Okay. Now let's find what is the sign of f dash of x on these each intervals. Okay. First of all, minus infinity to minus 1 by 2. Okay. See, minus infinity to minus 1 by 2, all the values are minus and less than minus 1 by 2. So when we substitute here x is equal to less than minus 1 by 2. See, all the values are minus, right? So if you substitute x is equal to any minus value, it will be minus, right? So it is minus. Okay. And what about this one? Here, see, substitute x is equal to minus 1 by 2 and less than minus 1 by 2. It is obviously minus, right? Because minus 1, so minus itself, right? So it is also minus. And see, if you are confusing, just substitute any value less than minus 1 by 2. Okay. Then, after that, here, put x is equal to minus 1 by 2. It is less than minus 1 by 2. So, here, when we substitute x is equal to 1 by 2, minus 1 by 2, here, minus 1 plus 1, 0. And less than minus 1 by 2, it will, obviously, it is negative, right? So, it is negative. Okay. See, when we substitute x is equal to minus 1 by 2, it is 0. Right? So less than minus 1 by 2, that is less than 0. Right? So it is minus. So total it is less than 0. Right? Minus into minus, plus, plus into minus, minus. Minus means less than 0. Okay. Next, minus 1 by 2 to 0. Next interval, minus 1 by 2 to 0. Okay. So in this interval, all the values are minus. And it is greater than minus 1 by 2. Okay. So what about the first term? See, here it will be minus. When we substitute x is equal to minus value, it is minus. Okay. Then this one also, here 2 into minus 1 by 2, that is minus 1, minus 1, minus 1, minus 2. So if you substitute, suppose substitute x is equal to 0, what you will get? Minus 1. So less than 0, that is less than 0, minus, right? So minus. Okay. Then what about this one? Put x is equal to 0 or put x is equal to minus 1 by 2. What you will get? Minus 1 plus 1, 0. Okay. Next, here values are greater than minus 1 by 2. See, just substitute minus 1 by 3. What you will get? That is minus 2 by 3 plus 1. That is, here also that is greater than 0, right? Positive value. Minus 2 by 3 plus 1 is greater than 0, right? So, here it is always positive. Okay, so whatever values you substitute between minus 1 by 2 to 0 here, you will get positive. Okay, so it is positive, therefore it is greater than 0. Minus into minus plus, plus into plus, plus. Okay, next interval 0 to 1 by 2. So 0 to 1 by 2, all the values are positive. So first term is positive. And what about this one? Here you substitute x is equal to 0. Okay, what you will get? 0 minus 1, that is minus 1. So if you substitute x is equal to 1 by 2, that is 1 minus 1, 0. So here if you substitute x is equal to 1 by 2, you will get, see, 1 minus 1, 0. So less than 1 by 2, it will be less than 0, that is minus. Right? And here obviously it is positive because we are substituting positive values. 2 into positive value plus 1, right? So it is plus. Therefore it is less than 0. Next, last interval 1 by 2 to infinity. All the values are positive and greater than 1 by 2. So first term is obviously positive. Okay, positive. And here what about this one? Substitute x is equal to 1 by 2. It will be 1 minus 1, 0 and greater than 0. Okay, means greater than 1 by 2. When you substitute x is equal to 1 by 2, it is 0. Okay, so greater than 1 by 2, it is greater than 0. Right? So here it is plus. What about this one? Plus. It is greater than 0. So here f dash of x, see, it is greater than 0 when x belongs to minus infinity, minus 1 by 2 to 0 and 1 by 2 to infinity. Right? So here in which interval? We can write the interval minus 1 by 2 to 0 union 1 by 2 to infinity. Okay. In this interval, f of x is increasing.